Now for the second factoring video, if you would like to factor by trial and error, which is probably the way you were taught in middle school, maybe even in ninth grade, depending on when you had it, is basically needing to understand that FOIL and factoring are opposite operations. So if we look over here at the quantity p plus 5 times p minus 4, and we FOIL it, what happens is you take first two terms times each other, and you get p squared. You take outside terms, and you get minus 4p. Inside terms, 5p. Last terms, minus 20. What always happens for us is that this outside and the inside term combine, and we would write our final answer as p squared plus p minus 20. Now what happens when we're asked to factor is I want to know, if I give you the trinomial, what two numbers it came from. So in the old days I might say, oh, 28. What are the factors of 28? And we'd say 1 and 28, and we'd say 2 and 14, and we would say 4 and 7. And those would be the factors. Well, now p squared plus p plus negative 20, what two numbers, thinking about quantities as single numbers, multiplied together to make that? Well, p squared and p squared, we drop 1 in there. You may remember this plus, essentially minus. There's a nifty table that if you have in your trinomial plus plus, your factors are both plus. If you have minus plus in your trinomial, your factors are minus minus. Plus minus, where we are right now, gives me one of each, and the order doesn't matter. Minus minus, one of each, and the order doesn't matter in the factor. So that means I have one of each. Now, understanding how this came from, where did 20 come from? 20 is my last. So these last two numbers have to multiply together to make 20. So what are the factors of 20? So trial and error, we would go ahead and we would put each of those factors in here and see then, where does 1p come from? Remember, that's outside plus inside, and we would run through all of our factors of combining outside and inside to get 1p. So for example, if I put 1 and 20 in here, I would have 1p minus 20p would be 19p. So that doesn't work. So we would erase it. And maybe we would put 20 and 1. Well, that would give me 20p minus 1p gives me positive 19p. Hence the name trial and error. And then we would start over and we would put 2 and 10. And that would give me positive 2p, negative 10p, which add together to negative 8p, and so on. And I don't like the messiness of trial and error there. So what I do is I make a little table for myself off to the side. And I say, well, if I have 1 times 20, that's going to give me plus or minus 19. And 2 times 10, if I add those and multiply and then add, that's going to give me plus or minus 8. And if I have 4 and 1, that's going to give me plus or minus 1. If I want my p to be positive, that means I want my 5 to be positive, my 4 to be negative. If I check, I have 5p inside, outside negative 4p gives me a positive 1p. And so that is your answer. If I look at this next example, I have the factors of 21, 1 and 21, 3 and 7, minus plus means I have 2 minus. So how are the factors of 21 going to go in there such that when I multiply them to the t's and then add them, because 2 subtracting is really adding, am I going to get 10? Well, obviously 3 and 7. And so we drop in a 3 and we drop in a 7. Order doesn't matter because negative 3t and negative 7t outside inside, negative 10 t. But you could have put the 7 here and the 3 here because the signs, it doesn't matter. Now those are pretty easy examples. What happens if I have a leading coefficient that's not 1? That's when things get slightly more complicated. But let's look at these first two examples, one of these first. What happens if I have a variable in the back also? Well, if we're going to drop our variable in the front evenly, we're just going to drop it in the back. Minus plus, minus minus. So now we're looking at the factors of 8. So when I add them together, I make 9. That clearly is 1 and 8. Do a check. Negative 1 xy, negative 8 xy, negative 9 xy. We're good. We are totally factored. Okay. Now, what happens when that coefficient isn't 1? Well, nothing initially changes. Plus plus, both plus, a k in each one, a k in each one. The only thing that's going to change now is that those two numbers as the first terms have to make 7. These two numbers as the last terms have to make 12. And by a combination of the two, outside and inside, we have to make 20. So this is where a table is definitely something I like to do. Here's my first, here's my last. So if I think about the factors of 7, 1 and 7, if I think about the factors of 12, 1 and 12, 2 and 6, 3 and 4, and I start combining them, and it's first, last, outside plus inside. So if I take 1 and 7, so if I put the 1 here and the 7 here, I'm going to experiment with different options. Times 1 from the 12 times 12. Well, that's not going to be 20. So I'm going to switch it. What if I say 1 times 12 and 7 times 1? That's not going to be 20. I've exhausted that one. 1 times 2, 7 times 6. That's going to be way too big because it's 42 or better. Switch that second factor, 1 times 6, 7 times 2, I have 6 and 14. Since I am adding plus plus, this is my combination because this equals 20 when I'm adding. This is a nice way to do it also because it tells me how to line them up. If I put my 1 here, then by connecting, my 6 has to go there. My 7 has to be in position with the k, but it is connected to that inside 2. So you take a quick check. Outside term, 14k. Inside term, 6k, 20k. Check your last. 2 times 6 is 12. Check your first. 7k times 1k, 7k squared. That is your answer. Now, in this next example, I have a greatest common factor I need to take care of, which we should always check first. And if I pull that 3 out, it becomes a much simpler problem of only having to look at the factors of 20 when they're subtracted to make 8. And so when you list those factors of 20, it's clear that when you subtract, you get 8. 10 minus 2. I want it negative, which means my 10 has to be negative. Take a quick check. 10ab negative plus 2ab negative 8ab. And that is how you factor with trial and error. A couple more examples where we don't have leading coefficients of 1. In this case down here, 8u plus 18uv plus 7v squared. We have a u in each one, a v in each one, plus 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 plus. So we have to figure out how do our factors of 8, 1 times 8, 2 times 4, combine with our factors of 7, 1 times 7, to make 18. So outside plus inside, since we're plus plus. So 1 times 1 plus 8 times 7. Way too big. 1 times 7 plus 8 times 1. That's 15. Still doesn't work. 2 times 1 plus 4 times 7. Too big. 2 times 7 plus 4 times 1. 14 plus 4. That's my answer. So the factor of 8 is a 2. It goes right here. That needs to get multiplied by the 7, which is a factor of the v. Factor of 8, which is 4, needs to go with the u. That needs to get multiplied by 1, which is a factor of the v. If you check outside, 14 uv, inside, 4 uv, 18 uv. First two terms, 8u squared. Last two terms, 7v squared. And everything checks out. So trial and error will work. It takes some monkeying around sometimes, making sure you have a good list of all of your factors. I wouldn't just start guessing. I would write them down, because the one you don't think of is the one that you will need. So good luck with your homework.